So we created a table called the fuzzy name search where we inserted the full name and the vector embedding vector of length 26, and we use the distance measure as a cosine similarity, and we can also use the L2 for the distance, which we actually have mentioned in the comment. So yeah, we have this function called def vector element, where we actually gave the list of alphabets in a particular list, and then the list of vectors which is actually initialized is all zeros. So in case if it was all 4 A's to the function, it will return the vector list as 4 in the first index, that is in 0th position, and then rest of all would be actually 0. So we actually created a database with 1 lakh of records using the Faker module, where we inserted a fake name in the Excel and then saved it in our file. So it also stores it along with the vector element, since we are using the vector element function here, and then we actually passed another name def Davis or Davis def for the testing case, where we actually got the name as well as along with the vector embedding of the particular name. Yeah, so how would you drop a file in TiDB? So you can actually use a drag and drop by clicking the above option, and then we actually managed to import 9.2 MIB file size. So coming on to our SQL editor, so going to the next function, so we actually limited our records to 8, and then we selected all the vectors that is actually less than or equal to 0.2. So we are actually limiting the amount of names, and so that the results can be more accurate. So here we pass a name def Davis. So basically Davis Jeff and Jeff Davis are actually kind of more or less similar, because the first and last names are actually only interchanged. So the cosine similarity is actually 0. But then Jeff Silva, Jeffrey Davis and all of the Jeffrey Davis are also same, because like it may not be accurate, but it's actually pretty close. Yes. So here we actually define whether we are actually using the index and whether it belongs to the particular table or not. Yes. Yeah. So we actually one second more. So we've also used the ANN and index here in the operator info, which actually shows the index that we have already used has been used here for sure. So during our project course, we actually had a lot of accomplishments that we are actually proud of, and we also have our own challenges that we actually ran into during the project. So first, I would like to say that we actually finished the project in very few hours, and yeah, the custom embedding is actually optimal in size of 26. So no strings that is actually less than 26 can be actually put into the function. Yes. So having vector search inside RDBMS, it actually brings the best of both worlds, and there is no need for having two different products. So unlike vector DB, which is actually hard to use, we had actually custom vector embedding, which we released in an article by doing a lot of research. And yeah, we need to get it up and running in kind of Milvest, and performance problem in Pinecone, and we also have peculiar errors in VB8, and the custom embedding work when we insert it, but kind of fail when we retrieve. So the error is reported to the VB8. So it is actually more transparent of vector data, unlike the vector DBs. So actually, if you're doing the vector DB for image, so we need to use the image beddings module in Python, and we actually use the image, the function ibed got to embeddings of image, and we actually got the vector, but we need to experiment so as to find the best way to give the vector embedding into the table. And size of the vector is actually defined. This actually ensures the data quality, and is a big plus when compared to the regular vector databases. So we are able to see the status of indexing, which is actually an additional plus and additional things. So once we have next vector based fuzzy name search, so comparing TiDB vector functionalities with other SQL databases exclusively built for vector data functionality. So we have MyScaleDB, which is actually developed from the code base of ClickHouse with vector functionality, and PG vector scale from TimescaleDB built on top of PG vector and Postgres. We also have a new type of indexing called the streaming disk on, which is inspired by the disk on, which is actually claimed that actually kind of more efficient.